Alright, so this is problem 25. And that one says that there's a hunter, or a guy, I think it's a hunter, I don't remember. Yeah, so a hunter on a frozen, essentially frictionless pond, which is that line. And then this is the dude, because I'm really lazy, and then he has a gun. Gun. Quality drawings. Anyway, so he shoots the gun, and there's a bullet that comes out of the gun. And the bullet has a mass of 4.2 grams. So that's 0.0042 kilograms, because units. And then it's moving at a speed of 965 meters per second. And then it says that the hunter with his gun is 52.5 kilograms. Is that right? 72.5, sorry. And then it wants to know what his speed is if the gun is shot horizontally and then with an angle of, what was it? I think it was 50 something above the horizon. 56. So, the way to solve this, is that all in? It's not. Let me shift this a little. Okay. So the way to solve this is pretty simple. The momentum before is going to equal the momentum after. Yeah. So I'm going to use the, yeah. So the mass of the hunter initial times the velocity of the hunter initial plus the mass times the mass of the bullet initial times the velocity of the bullet initial is going to equal all of that except after. So since this is all zero, I'm just going to go ahead and remove this and get rid of the initials. So this is all going to be equal to 0. And then we can go ahead and move over the hunter to the other side, which will make it negative, but that makes sense because you're shooting this way, so he's going to get pushed this way. So if you go ahead and plug things in, you get that 72.5 times velocity of the hunter equals 0.0042 times 965. So you just go ahead and divide all of that by 72.5, and you get that equals, where is my cheat sheet? 0.559 meters per second that he's moving backwards. So that's the answer if he shoots the gun straight over. But if he shoots it up at an angle, part of the force is going to get absorbed by the normal force. Because you can split this into like your two different things. So there's a force that's going up on this, as well as a force that's going over. Only this part of the force here is going to make him slide. This part is just going to increase the normal force that is like the reaction from that. So we're just going to use this. So we're going to take the sine. So sine equals the opposite over hypotenuse. Is that the one we want? I think we actually want the cosine. Right, because cosine is going to be adjacent over hypotenuse. So yeah, sorry. Cosine equals the adjacent, which is going to be what we're trying to find, over the hypotenuse, which is going to be the same as this one because it's getting pushed out the same speed, so that's the same. So that's going to be our 72.5. So what you do, this is our theta, which is 56. I just don't have enough room to write that in. So 72.5 times cosine of 56 equals your x, which is going to be equal to 0.03126 meters per second. So that's our two answers.